Hey y'all, we are Memphis Community University and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. Today we're going to be talking about slope fields, which is a continuation of our differential equation unit. So while it's not as important as our first lesson, which is separate and integrate, slope fields is still a very important topic. It comes on both the multiple choice and the free response questions of both the AB and the BC exam. What we're going to see today is that slope fields is pretty easy. All we're going to be doing is drawing pictures or looking at pictures and trying to gather information from that picture. So it shouldn't be the worst question in the world. Keep in mind, you might be wondering what is a slope field. That is certainly a good question. So a slope field is basically what it sounds like. It's a field of slopes. So we're going to start off with a differential equation, which we introduced in our last video. And a differential equation is just an equation that has a derivative. Then we're going to plug in certain points and we're going to try to examine into that differential equation. We're going to try to examine the slope at that point. We're going to draw a little line segment. And the benefit of slope fields, or the use of slope fields, is that once you have your entire slope field with all your little slopes, then what you're going to see is that you're going to be able to find graphs of the particular solutions to that differential equation. So again, our goal is going to be all about slope fields today. We're going to start off with a free response question where you draw your own slope field. Then we're going to move on to multiple choice questions where the best shortest strategies is process of elimination. We're going to give various hints, like you should try to see if the slope fields depend on X, Y, or both, and also where the slope field is 0. But let's get started. Let's start talking about slope fields. So here we are, we're talking about slope fields. And again, in these questions, there's going to be a given differential equation when it's on the free response question. So it's going to be dy dx is equal to, let's do x minus y. And then we're going to have these dots here. So 0, let's draw these dots. 1, 2, 1, 2, and then so on. So what's going to happen is that you're going to take this given differential equation, and at each of these 9 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to plug in that point into this differential equation. We're going to get a slope, and then we're going to draw this little line segment that has that slope. So keep in mind, of course, that we have the x's and y's, so that's why we have 2 coordinates. So let's try to do this. Let's try to take any of these lines. So I'm going to take this point right here first, 2, 1. So what I'm going to do is we're going to plug in 2, 1 into this function. Notice that when you plug in 2 minus 1, 2 for x, 1 for y, because it's x coordinate 2, y coordinate 1, you're going to get 1. So that slope kind of looks like this. If you know a slope of 1, y is equal to x is an example of such a line. The slope is basically at a 45-degree angle. So I drew a little line segment with that slope. Sometimes my students like to write out what the slope is because they're not perfect artists, sort of like me. My pictures aren't incredible, but hopefully you get the picture. Let's start doing some more points. So now we have the point 2, 0 here on the bottom. Again, all we're going to do is plug it into the function. 2 minus 0 is 2. So we want to have slope of 2 in this case. How do we distinguish between slope 1 and 2? Well, we just want to make a little bit steeper. I'm assuming that anybody who grades any assessment that has slope fields aren't going to pull out a protractor and make sure that it's sloped whatever you need to be. Just make generally sure that your positive slopes are positive, your negative slopes are negative, your 0 slopes are perfectly horizontal, and if one slope is steeper than the other, then it should be steeper. So let's keep going with these 9 dots. Hopefully you see what I'm doing here. So let's say that this one is 2, 2, because it's 2, 2. What you're going to do is you're going to plug in the x coordinate and the y coordinate again. Looks like they're both 2, so it's going to be slope 0. Slope 0 is the one that I can perfectly draw because it's going to be a perfectly horizontal line. Let's keep going. What other ones have perfectly horizontal lines? But that's when x coordinate and y coordinate are the same. So it looks like at 0, 0 here, the slope is also going to be 0. So we're going to bold this as best as possible. And this is equal to 0 in this case. Same thing with 1, 1, because the slope is 0. Because you're plugging in 1 minus 1. So it looks like we're almost done with this question and it's not going to be too bad. This guy, this point is 1, 0. What's the slope at that? Well, we're going to plug in 1 and 0. 1 minus 0 is 1. So that's going to be slope 1, which looks like our little line segment. Then we have the point 0, 1. Well, when we have the point 0, 1, this 0, 1, when we plug this in, it'll be 0 minus 1, which is negative 1. So this is our first negative slope. We want to make sure it's negative. So we're going to make it negative. Negative 1 slope. We can write m is equal to negative 1 on the side here. Finally, let's finish this off 1 minus 2, that's also going to have slope negative 1. So 1 comma 2 has slope negative 1 as well. And then finally, when you plug in this point, this last point is going to be 0 comma 2. When you plug this in, it's going to be 0 minus 2, which is negative 2. So negative 2, and again, you can label it if you want to show that I do know what the slope is. Sometimes my graphs aren't perfectly perfect. So this is how you do slope fields on the free response questions. Hopefully that makes sense. Again, all you do is you plug in the x coordinate or the y coordinate into your function, and you're good to go. So that's going to be our slope fields. This is a very tedious process on the free response questions, but students don't tend to hate it too much because, again, all you're doing is plugging in numbers, seeing a little slope, and drawing a little picture. It does take a little bit of time to do it at 9 different points, but it's not the hardest thing in the world, so I'm willing to do it. Now, the harder questions, in my opinion, are going to be multiple choice questions, so the rest of the video is going to be talking about multiple choice questions. Basically, instead of starting with the differential equation and coming up with a slope field yourself, what you're going to have are slope fields that are already provided, and you're going to be answering questions on those slope fields. So before we start that, before I draw any slope fields on the board, I'm going to give you some hints for these multiple choice questions. So slope field multiple choice question hints. So your first hint is that you want to be able to find where your slope is 0. Notice in that first question we were easily able to identify where slope was equal to 0. Usually that's the case in most differential equation free response questions. And a lot of times these slopes are 0 in rows or columns. So for example, if you see a row of x equaling 0, so if we have a column of zeros, let's say we have something that looks like this in our slope field, and this is at the point 2, then what we know is that x is equal to is going to be a 0 of our differential equation. So for example, we want to choose something like x minus 2 times y, because when we plug in 2, we'll get 0. Same thing with our row of zeros, but with the opposite. If you see a row of zeros, let's say that this is at y is equal to 3, what happens is that when you plug in y equals 3, you want to get 0 for your differential equation. So we're going to be looking for these columns of zeros and rows of zeros. My next hint is to try to determine if the differential equation only depends on x's or only depends on y's. So if it only depends on x's, that means that every single column is going to be the same as you go along the column. Meaning that if you look at one column, every single slope from top to bottom of that column will be the same. So you're going to have something that looks like this. I'm not going to draw a perfect picture, but hopefully this makes sense. All of these slopes are supposed to be the same. All of these slopes are supposed to be the same, no matter what column you're looking at. So you're going to have something like this. These are supposed to be perfectly vertical. So when you have these, you're going to be choosing differential equation that only have x's because they only depend on x's. So you wouldn't choose something like x minus 2 times y. You would only choose something maybe like x minus 2. The same as, this is not my best picture, so I'm going to actually make it a column. So let's make it a column actually. These are hard to draw. So let's make this a column actually. So hopefully you see that we're going to have these differential equations where again, along each column, it's going to be the same. So we're going to choose answers with only x's. There are some that depend only on y's, which again means that our differential equation in the multiple choice or in the quick givens has to only depend on y's. And when it only depends on y's, that means that every row will be the same. So you're going to have something like this, where along each row, it's going to be the same slope. So it's going to look like this. So notice along the columns, they're changing, but along the rows, they're consistent. So just these two will be able to answer a lot of the questions. Again, what we're going to try to look for is where things have slope zeros, columns of zeros, rows of zeros, and finally, we're going to see if things depend on only our x's or y's. Things that don't depend on x's or y's mean that along columns and along rows, you're going to be changing. So the answer will probably have x's and y's. So it's either going to only depend on x, only depend on y, or both. If it depends only on x, every single column, the slope is going to be the same. If it depends only on y, every single row is going to be the same. If it depends on both, along columns and along rows, the slopes are changing. Finally, Our last hint is to really just plug in numbers. If you're having a lot of difficulty, what you're going to do is you're going to do the reverse of the first question. You're just going to plug in numbers and see if that slope has that line. But when you plug in numbers, one thing you might want to focus on is quadrants. So if you look at these quadrants, just try to focus on positive and negative when you find these quadrants, because a lot of these pictures, we'll see one example in particular where all the slopes are positive in certain quadrants, and that allows us to answer the question pretty easily once we examine the multiple choice answer choices. So when you're plugging in these numbers, don't really fixate on the 2 versus the 1. Really, again, you're basing it on big groups of points, or if you see a slope that's negative, that should be positive, or positive, that should be negative, then you'll know that that's not the answer choices. But again, these are our 3 main slope field hit multiple choice questions. We're going to see where columns are slopes, columns are zeros. That will mean that x is equal to 2 solves the differential equation or makes the differential equation 0. That's a better way to say it. Same thing with rows being 0. That means that if we plug in, for example, y equals 3, we're going to want 0, something like y minus 3 times x. Then we're going to see if it depends only on x or y, depending on if the columns are changing or the rows are changing. And finally, we're going to plug in random numbers or random points. So maybe we should change this to random points because we have x coordinate and y coordinates to be a little bit more precise. And sometimes it's all going to be based off quadrants. Like if an entire quadrant, like quadrant 3, all of the slopes are positive, we're going to be looking for differential equations with positive slopes in the 3rd quadrant. So that's going to be our 3 strategies. This is going to be a process of elimination, and for every single one, because I don't want to waste time drawing these pictures or waste your time because they're pretty precise, I'm going to cut the video and we're just going to do each one individually. So let's start with the first one. So let me erase this. So this is going to be our first slope field multiple choice question. What's going to happen is you're going to have a given slope field. It's not as pretty as a computer generated one, but it should suffice in order to help you guys out with slope fields. And then you're going to have multiple choice answers. So the question is, which of these 4 differential equations satisfies this slope field? So we are going backwards than those free response questions. In the free response questions, we started off with a differential equation, then we drew a slope field. In this case, we're starting off with a slope field, and then we're trying to come up with a differential equation. So this is how it works. So again, remember our 2 main strategies. Our first main strategy is to find where slope is equal to 0. See if you can see a column of zeros and rows of zeros. So let's see if we can do that. So notice that along this column right here, we have perfectly horizontal slopes of zeros. So along this column, so we're going to indicate this column right here, this is where we have slope 0. So we want to recognize which column this is. Notice that it's, well, x is -1, x is -2. So it's going to be x is equal to -2. We should probably label this 1, -1, -2, -3, 1, 2, and 3. So along this column of x's, x is equal to -2, we have a column of zeros. So what's going to happen is we want to plug in -2 into our differential equation, and we want to see if it makes 0. Because if it doesn't make 0, it can't be the differential equation because this slope field has zeros at x equals -2. So notice when you plug in -2 into this, you're not going to get 0. You're going to get -2y. So that's why this cannot be the answer. -2y does not equal 0. When you plug in -2 into this, you actually could get an answer because when you plug in x is -2, you get -2y plus 2y. That is 0. So this potentially could be still a candidate for the answers. Then if we plug in -2 in this case, notice you're going to get -2y minus 2y. When you plug in x for -2, that's minus 4y. That is not 0 in every single case. So we know that this is not the answer. Finally, when you plug in -2 into this final answer, it looks like that could be a possible answer choice because you do get 0. So it looks like we wrote it down in B or D. That's half of our work. Now we're going to go for the other half. So if you notice along these columns, our second strategy is to notice whether this depends on x or y or both. So let's take any column. So if you look down this column right here, for example, notice that the slopes are changing as you go through the column. You have positive slopes here that are becoming less steep, then you have negative slopes right here. If this only depended on x, what it would look like, it would look like something like this, where every single slope along the column, maybe if I can do it correctly, like this, where every single slope is consistent along the column, and it would hold for every single column, not just that one column. So again, a slope field that only depends on x has columns that are consistent along the column. A slope field that only depends on y has slopes consistent along rows. So in this case, we are not dependent on x or y, we depend on both. So notice again, as you go along this road, the slope is certainly changing. So this differential equation depends on x or y. So now we're going to look at our answers. Well, it looks like answer choice B does have x and y, so I'm going to go for that one as opposed to answer choice D. Answer choice D only depends on x's. It only has x's in it, which would mean that every single column, as you go down the column, the slopes would be the same. So this is not the answer. This is the answer. So hopefully you were able to see that through a process of elimination, we were able to find this question. What we did is we first recognized where a column was equal to zeros. In this case, it was x is equal to -2, and then we plugged it in. Finally, we looked at whether something depends only on x or only on y or both. And in this case, our slope field depended on x or y, so we ruled out the one that only had x's in it. And that's how you do these questions. So let's try again. So this is going to be our second multiple choice question with this slope field that is given. And again, what we're going to do is we're going to use the same two strategies, find where slopes are equal to 0, and also find if this depends on x, y, or both. So if you look at this slope field, it looks like we don't have any columns of zeros, but we do have one row of zeros. It's going to be right here, this row right here. Notice that along the row, the slope is always 0 consistently. So what is this row? It looks like it's going to be y is equal to 2. So what we're going to do is we're going to plug in y is equal to 2 in each of these differential equations, and we're going to hopefully get 0. And that's going to be a possible answer choice. If we don't get 0, that cannot be the candidate for the right answer, because again, this slope field has slope 0 at y equals 2. So when you plug in 2, you should be getting 0. So notice if you plug in 2 here, you're going to get 2 plus 2, that's 4. 4x. 4x is certainly not 0. So looks like A cannot be the answer choice. Then when we plug in B, 2 for y, keeping in mind that it's y is equal to 2 and not x is equal to 2. When we plug in y is equal to 2, looks like B potentially could be an answer choice because you do get 0 times x. Now for C, well, when you plug in 2, you're just going to get 2 plus 2. That's obviously not 0. 4 does not equal 0, so that cannot be an answer choice. And finally, it looks like D can potentially be an answer choice as well, because when you plug in 2, you will get 0. So looks like our two possible answer choices are B and D from our first strategy. Thankfully, we have our second strategy. So our second strategy is to look along columns and to look along rows, and are they changing or not? So if you look along columns, they're definitely changing. Like this is a positive slope, then a 0, and then a negative, and so on. But hopefully you can don't mind the limitations of my artistic abilities. But if you look on every single row, no matter what row I choose, notice that the slopes are all 0. Or not all 0, but are all the same. Consistently as you go along a row, the slopes don't change depending on the x's. That means that this slope field depends only on y. And the fact that this slope field only depends on y will allow us to answer this question. So what's going to be the right answer? Is it going to be B or D? Well, B, notice, has y's and x's, so it depends on both of them. So we're going to choose D because D only depends on y. That's going to be our right answer choice. So it's still the same strategies as the first one. We found a row of zeros to eliminate certain answers because we plugged in that number and we were supposed to get 0. And then finally, we saw that this one depends only on y, so that's why D was the answer. So these two strategies usually work for a majority of the questions, but there's some slope fields that this doesn't work with, and that's why we have to use our third strategy eventually, which is just look at things based off quadrants potentially, and see if you have positive or negative slopes at random points. So unfortunately, you can't rely on the strategies that we talked about in the first two questions for every single slope field question that you might see. For example, this one. So if you notice, look at the numerators of each of these fractions, these answer choices. They're all x is equal to 0, so they're going to have the same place where you have slope zeros. Also, all of them have x's and y's, so they all depend on x and y. They don't depend on x only or y only. So we cannot use those answer choices because they don't help us rule out the answers at all. So our third main strategy when we do these slope fields is to look at positive and negative slopes, because sometimes it's easy to eyeball where slopes are positive and negative, especially in big groups of points. And what we're talking about is usually quadrants. So if you look at our slope field right here, notice that, if you can sort of ignore the inexactness of my graph, where my slope is, but notice that in this first quadrant, you all have positive slopes. Some are certainly more steep than others, but you all have positive slopes. Same thing with the second quadrant. Every single slope in the second quadrant is positive. And finally, in the third quadrant and the fourth quadrant, so we'll label these quadrants, first, second, third, and fourth. Notice that in both the third quadrant and the fourth quadrant, every single slope is negative. It's going to be going down. So what we're going to do is we're going to plug in certain various points into these differential equations right here. And we're going to see which one matches that pattern, that you have positive slopes in the first two quadrants and negative slopes in the last two quadrants. So let's take this one right here. For example, x, y. So when you're doing this, you can plug in any single point within the quadrant. I'm going to plug in the point 1, 1. So 1, 1 to represent the first quadrant. Then I'm going to plug in this point right here, which is negative 1, 1. And then I'm going to plug in negative 1, and I'm going to plug in this final point for the fourth quadrant, which is 1, negative 1 into each of these guys. So for example, when you plug in 1, 1 into this right here, you're going to get something positive. So I'm going to write positive there. Then when you plug in a representative point in this quadrant, again, the best one, in my opinion, to represent this quadrant is negative 1, 1. Notice that you'll get negative 1 over 1. That's a negative number. Then for the third quadrant, we're going to represent that by negative 1, negative 1. When you plug that in, you're going to get positive. Negative 1 over negative 1, the negatives cancel out. Finally, if you plug in any point in the fourth quadrant, including the point 1, negative 1, you'll get a negative. So notice that this picture does not match this picture, so A is not the answer choices. Because it looks like we have negative slopes in the second quadrant, but our picture is of positive slopes in the second quadrant. Let's do some as well. So this quadrant is actually going to be pretty easy. Notice that this is x squared and y squared. So no matter what point you're going to plug in, if it's within the quadrants and not exactly on the axis, you're going to get positive for everything. Because anything squared is positive when you have non-zero things. So for example, when you plug in 1, negative 1, well, that's going to be positive. Any single point you plug in is going to be positive. So that's why D can't be the answer choice. So let's quickly follow in these quadrants for the last two. So I'm going to quickly do that. Well, in both of them, when you plug in positive things, of course, you're going to get positive things. So each of these have positive first quadrants. Then let's try to take the other quadrants. So if you take this quadrant right here, that's quadrant 2. Again, we're going to represent that by the point negative 1, 1. When you plug in negative 1, 1, negative 1 squared will be 1 over 1. That's going to be positive. Then if you're looking at this quadrant 3 right here, well, we're going to plug in something like negative 1, negative 1. The negative 1 will again square, so you're going to be left with 1 in the numerator, and you're going to divide it by negative 1, so that's going to be negative. Then for this quadrant right here, when you plug in a representative point, for example, 1, negative 1, well, the 1 will square in the numerator, so it will still be 1. Divide by negative 1, it looks like it's going to be negative on the bottom. So I think my answer is going to be B, but let's check with C. Because look at B, it looks like it matches. Positive slopes in this quadrant, positive slopes in quadrant 1 as well, and then negative slopes in the bottom two quadrants. But let's try to see this out. So let's just do the same thing. We're going to plug in these representative points. So when we plug in negative 1, 1, so negative 1, 1, looks like we're going to get negative 1 on the top, and then the 1 squared will be 1, so it's going to be negative in this quadrant. If you keep going, well, if you plug in negative for both things, the negative 1 will cancel out in the denominator, so you're still going to have a negative in the numerator, so it's going to be negative in this side. And then finally, if you plug in something in this quadrant, well, it's a positive x, and then a negative that's being squared, so it's going to be positive in this quadrant. So notice again that the answer is B. This is going to be our strategies. You don't have to like look at this picture and be like, oh, this is definitely this differential equation that corresponds to the slope field. What you can do is you can do little patterns and tricks and things like that. In this case, we broke it off into quadrants when everything is a fraction and we weren't able to use our first two strategies. But let's just do one more of these slope field questions and then we will do another one after that, I guess. So let's do another one. So now we are going to use everything we learned about these slope field multiple choice questions to answer this final multiple choice question where all the choices are the differential equations. So what we're going to do is we're going to do our various strategies. Looks like we can't use our x and y strategy though, depending on x or y, because all these answer choices both have x and y. So we're not going to have every single column be the same. So notice this column is changing quite differently. These rows are changing differently. But we can use our other two strategies to find this answer. So first off, what we're going to do is we're going to try to find where slopes are 0. So keep in mind that usually in the easier questions, slopes will be zeros along rows and columns, but in this case, it's actually around a different line. Notice that this is slope 0, 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 and this is slope 0. So it's not around along a vertical line, which would be x is equal to 2, for example, or a horizontal line, which is equal to y equals 2. It's along this line right here. What is this line? This is the identity line. Y is equal to x. So what we're going to do is we're going to plug in y for x, and we're going to see what we get into these differential equations. What we want is we want to get 0. So if we substitute in y for x, we're going to get x minus x. That's going to be 0. So that is potentially still an answer choice. Then we're going to do the same thing here. If we plug in y for x, you're going to get x minus x. That's still going to be 0, so that's potentially an answer choice. When you plug in y for x in this case, looks like you're going to get x plus x. So you're going to get 2x. That is certainly not 0, so that cannot be the answer choice. Finally, when you plug it into this last one, x over x, that's going to be 1. That is also not 0. So it looks like, again, using the strategy of seeing where slopes are 0, you're able to rule it down to 2 answer choices, and now we have to do a further strategy. So it looks like the easiest strategy will, again, be based off quadrants. Some of these quadrants are a little bit weird. Notice that in the first quadrant and the third quadrant, slopes are both positive and negative, so I don't want to use those quadrants as my answers, but I can use either the second quadrant or the fourth quadrant. So notice that in the fourth quadrant, every single slope is positive, and in the second quadrant, every single slope is negative. So you only have to use one. Let's try to do something in the fourth quadrant. So a good representative point of any slope in the fourth quadrant will be -1. Not -1. 1. We want positive x's, negative y's. Positive x's, negative y's. And what we want is we want to get something that results in something positive. So what we're going to do is we're just going to plug in this point into these two things, and the positive one will be the answer. So when you plug it into right here, 1 minus -1, that's going to be a positive thing. That's what we want. If you plug it in here, notice it'll be -1 minus 1. That's a negative thing. So this cannot be the answer choice, because for answer choice B, slopes in the fourth quadrant are negative. But if you look at our picture, every single slope in this fourth quadrant is positive. So that's how you answer these slope field questions. If you use the strategies that we sort of aligned, you're using the fact that you're taking a standardized test with multiple choice questions to not find the right answer choice, but to eliminate the wrong 3. And how you eliminate it is through 3 main strategies. The first strategy is to see where slopes are 0. That means every column is 0 or a row is 0. Potentially even like the identity line or the negative identity line. If you can identify if a line or a row or a column is 0, plug that into the differential equation and you want that to result in 0. The second strategy we did is, does it depend on x or y or both? If it depends on just x, that means that along every single column, the slope won't be changing. So it'll be tick mark, tick mark, tick mark, tick mark, tick mark, and it won't be like this where it's changing throughout. If it depends only on y, that holds when you're going along rows. Every single tick mark is the same as you go along the row. This is not the case in this. If it depends on both x and y, you're going to see something that looks like this. Every single row, the slope is changing. Every single column, the slope is changing. So that will dictate which answer choices you want to choose. The final thing we are going to talk about, the final third strategy we talked about is depending on positive or negatives, depending on quadrants. If you can group a large number of points, the quadrants, and see that, oh, every single point in this quadrant, the slope is positive, or every single point in this quadrant, the slope is negative, you can plug in representative points, usually 1, 1, -1, -1, -1, -1, and then finally 1, -1 for the fourth quadrant into your potential answer choices, and you will sort of compare the signs. Is this negative in the right quadrant, according to my picture? So those are the 3 main strategies. We have one last slope field multiple choice question to go, and that's going to be quite a different question than all of these. All of these had answers that were dy dx. For the last one we're going to do is we're going to have a slope field question, but all the answer choices aren't the differential equations themselves, they're the solution to the differential equations, and you'll see how that works. So let's do that question. So this is going to be our final question on slope fields. This is going to be a slightly different question than all the other ones that came before. Again, notice that the answer choices are not dy dx equals something, dy dx equals something, dy dx equals something. They're not the differential equations themselves. They're actually the function. Y is equal to ln of x, y equals x cubed, and so on. So in these questions are a lot easier in my opinion than other questions. I've seen these questions also in free response questions when they give you the slope field already provided. And what we're going to do is we're just going to sketch the solution to the differential equation with the initial point 0, 0. So they always give you an initial point like f of 0 equals 0, or in this case 0, 0. And all you do is you plot that point, then you sort of follow your kindergarten skills. You just try to follow the flow of the slope field, try to connect some lines here and there, and then you're going to admire your picture, step back, and just see which graph you drew. You don't have to do all this business with dy dx's because these are not the slopes themselves. These equations, these are the equations that have certain slopes. So let's see that in action. So again, the first thing to do is just boldly plot the point that they give you, 0, 0. And then what you do is you slowly try to follow the lines and connect them as best as possible. So it looks like I'm going to go up here, and then I'm going to go down here if I'm following the flow. And then it looks like I'm going to go down here and up here. And then once you sort of boarded this line, just try to recognize which graph you drew. In this case, it's definitely not ln, definitely not x cubed. And because it's a trig function and it goes through the origin, looks like we graph y is equal to sine x. So these questions are pretty simple. Again, what you do is you plot the point. If the solutions to the differential equations are the thing you're looking for and not the differential equations themselves, plot that point and slowly follow your way through. And again, you might be doing this on free response questions where they give you a slope field already provided. They give you an initial point and they tell you to draw this, the solution or the particular solution to that differential equation on the slope field. And what you do again is you plot that point and you just follow the lines and you just see what graph you drew. And in this case, after you enter these multiple choice questions, you should be able to recognize it. This is y equals sine of x. So that's our video on slope fields. Hopefully this was useful for you. But again, my slope fields were of course hand-drawn. If you want to see computer-generated slope fields, the ones that are like the AP exam, then be sure to check out our Girls Teach Calculus video, where one of my former students practices these questions virtually, so she has computer-generated ones, but she goes over everything that we covered today. She does the dot question where she draws the slope fields herself on the dots provided. Then she does various multiple choice questions where the answers are dy dx, and she talks about our three main strategies: finding where slopes are 0, seeing if it depends on x and y in both, and then grouping quadrants that have the same sign in order to answer these questions. So be on the lookout for that. I highly encourage you to watch that video. And if you've watched this video and you found it useful, please give us a like and subscribe. It definitely helps out our channel. We're going to be continuing our differential equation unit with various small lessons that are not as important as slope fields or certainly separate and integrate. We of course encourage you to watch that separate and integrate video. That's the most important thing. But we're going to continue with the differential equation stuff, A, B, and BC stuff like exponential growth and decay, but also like logistic growth for just BC only topics. So whatever you choose to do, thanks again for watching, and I hope to see you next time.